Okay, problem 5. By changing to polar coordinates, evaluate the following integral. Right, so how do you do the polar coordinate? So it's r3y dA. Okay, what is a polar coordinate? Actually, for a certain point, right, you can describe it by x and y, right, which gives us the xy coordinate. Okay, this is a y, this is the x. Okay, but we can also describe it by r and theta. Right, so what is this r? R is the distance from the point to the origin. Right, so r squared, because it's a right angle triangle, so r squared is x squared plus y squared. Okay, and also tangent theta is going to be y over x. This tangent theta is the angle, right, from the positive x-axis, and you rotate it counterclockwise all the way until this, right, this line. Then what's that angle? Okay, so you can see clearly from the graph that tangent theta is going to be y over x. Okay, and what about y? Y is just r times cosine theta, right? X is just r times sine theta. Okay, so first question. So you want to integrate 3y. So first 3y, right? It's 3r cosine theta. Okay, and always remember your dA is r dr d theta. Okay, so it's always r dr d theta. Don't, especially this r. It's very easy to forget about the r. So it's r dr d theta. Okay, then what about the range of r, range of theta? You have to draw the graph. Okay, here it's a circle of radius 2 centered at the origin. Okay, so this is a circle with radius 2, which means what? Which means, what is the theta? Theta is from here, you can rotate it 360, right? With no limitation. So it's free, theta is free to increase from 0 all the way to 2 pi. Right, what about r? R, just any point within this circle is okay, right? So any point within the circle, its distance from the origin is between 0 and 2. Okay? So all you need to do is do the integration. Alright, so first I have a 3, it's a constant, I can move it out. And then for r squared cosine theta dr d theta. Right, so integrate r. It's going to be 1 over 3 r cubed. Right. So cosine theta, you can move it outside. Right, for r from 0 to 2. Okay. So this 1 over 3 and 3, they can be cancelled out, which is just 0 to 2 pi cosine theta. Right, r cubed, which is 8, right, d theta, which is just 8 sine theta from 0 to 2 pi. Okay? I'm so sorry. From the beginning, it's wrong. I'm so sorry. It's a typo. Your r, obviously, your y over r is cosine, right? I mean, your y over r is sine. Sorry. Y over r is sine, and your x over r is cosine. Okay, obviously. So, sorry about the typo. So all the way, it should be sine. Okay. Okay, so you integrate sine, you get negative cosine. And both cosine 2 pi and cosine 0 are 1, so the result is just 1 minus 1. It's 0. Okay? Sorry about the typo here. It's, yeah. Y is r sine, x is r cosine. Okay? Right. Now let's do part B here. Okay, let's do part B here. So now it's double integration x plus 2y dA. Okay, so now the region is first quadrant bounded by a circle centered at the origin and with radius 3. Okay, so now it's a first quadrant, which means what? So first, dA is r, dr, d theta. Okay, what about theta now? Theta now is from here to here, right? So it's from 0 to half pi, okay, because it's just the first quadrant. And the r is just any point within the circle. Its distance from the origin to the point is between 0 and 3, right? So r is from 0 and 3. Okay, what about x? X is r cosine theta. Y is r sine theta. Okay, so this is it. Then you just need to integrate this. Okay, then you just need to integrate this. So it's from 0 to half pi. So you can see if you integrate r. Okay, so the first part is cosine theta r squared. The second part is plus 2 sine theta r squared. Okay. So this part is going to be cosine theta times 1 over 3r cubed, right, plus 2 sine theta, right, plus sine theta times 2 over 3 r cubed, right, for r from 0 to 3. Right, which is just 9 cosine theta plus 18 sine theta. Okay, d theta. Right. And just have to do the integration. It's going to be 9 sine theta minus 18 cosine theta. For theta from 0 to half pi, right? You just do the calculation and simplify it. You'll get the answer 27. Okay. You'll get the answer 27. Okay. Part C. So now it's y squared over x squared plus y squared dA. Okay, so now the region is bounded by two circles, a smaller circle with radius 1 and a larger circle with radius 2. Okay, so now let's do the standard part. For example, dA is r, dr, d theta. Okay, what about y? Y is, okay, again, whenever you are confused, like me just now, you can draw the triangle, right? This is y, this is x, this is theta, this is r. So y is r sine theta, x is r cosine theta. Okay, so it's y squared, which is r squared sine theta squared, over, okay, r squared cosine theta squared, okay, plus r squared sine theta squared. Okay, I have an r here. Okay, then what about the double integration? So now for theta, it's still 360, right? For theta, it's still from 0 to 2 pi. And what about r? R is from here to here, right? So r, it should be greater than 1, but r, it should be smaller than 2. So it's from 1 to 2. Okay, then let's simplify it. From 1 to 2, this top is just r squared, right? R cubed sine theta squared. Okay, this bottom, because I have cosine theta squared plus sine theta squared, right, which is 1. So over r squared. So dr d theta. Okay, so it's actually just r sine theta square dr d theta. Okay. I'm sorry, here, this circle, right, x squared plus y squared is 2, so the radius is what? It's square root of 2, okay? It's square root of 2. So, can do the integration, so sine theta square. Okay, it's half r squared from 1 to square root of 2 d theta. Okay. So it's just half, right, from 0 to 2 pi sine theta square d theta. Okay, now to do this part, you have to change it, right? Because cosine 2 theta is 1 minus 2 sine theta square, right? So the sine theta square is just 1 minus, sorry, it's just, it's 1 minus cosine 2 theta over 2. Okay, so it's just, you integrate, right, 1 minus cosine 2 theta over 2 d theta, okay? So this 2, you move it out, so it's 1 over 4. Okay, theta minus sine 2 theta over half, right, from 0 to 2 pi. Then you just do the substitution. Okay, you will get the answer. It's half pi. Okay, sorry again for the typo here. Okay.